The objective today is to discuss the information flow to pipers and explain the overall information flow about engineering stakeholders and about equipment and piping layout. In particular, I want to define the main owners and immediate downstream users of block flow diagrams, process flow diagrams, P&ID diagrams, piping material specifications, equipment data and drawings, and piping layouts. Now, if anyone gets lost or something is not clear, please, Catherine, speak up, okay? And I don't want to lose anybody. This is an overall view of the information flow, and it's helpful to explain these different data owners and how they contribute to other data owners and what documents and data sets are derived. Let's begin with the block flow diagram. This is this block flow diagrams explain the business case for the plant. In particular, can you see this now? Are you seeing this now?
Yes, Paul.
Okay. In particular, the block flow diagram explains the business case for the plant. That includes the finance, the processes, the sales, the input-output logistics. And it's only in terms of major elements or blocks and the flow between them. It's normally owned by the client. It is owned by the client, who's the economics owner. The economics owner then flows this data to the process owner, who's also normally the client, but he relies on the business case to size and quantify the process streams and the major units. Economics owners will update the business case with the new process details, and this whole collaboration is often referred to, it's normally referred to as, this whole collaboration is part of what's referred to as front-end engineering design, or FEED. The process flow diagram shows unit operations and streams. It establishes the major process conditions, and in particular, the contents of the pipes, vessels, and equipment, and also their performance. It's owned by the clients, who's the process owner. The business case in the PFD can be thought of as a question. Everything following is an answer. The client asks, can you implement this? And the engineers and planners design an answer. Procurement, fabrication, construction, and startup implements the answer, and acceptance test and production proves the answer. There are multiple owners who take data from the process, from the PFD. These are material integrity owner, the equipment owners and vendors, the controls and stability owner, and the environment, health, and safety owner. There's a lot of spelling errors on this I have to correct. The environment, health, and safety requirements set the are part of the overall EHS integrity of the plant. This includes process materials and hazards, hazardous properties and conditions, biohazards, electrical classification practices, site climatic conditions and impacts, environmental effects and permitted discharge and release levels. It's checked by reviews such as the process safety analysis, and it's owned by the EHS integrity owner. Now, since we know the contents of the pipe from the PFD, we can now decide what materials we can use. And these are design and these are specifications of the material, the design and test temperatures and conditions in the pipe, and it's normally pre-specified by the service in the streams. You get presets of specifications for different service types like seawater, flares, potable water, and so on. These are predefined material specs. The piping material specs dictate the pipe, valves, and fittings, the specified flanges and blinds, etc., and it's owned by the materials integrity owner. The pipe spec can change when the process conditions change. In this case, here's a drain line that's not subject to the same severe conditions as the main line above. And so the spec changes at the drain line because it's less critical. Okay, you guys still seeing the slides? Are you still seeing the slides?
Yes, Paul.
Yes.
Yes.
Okay.
Yes, we're seeing the presentation mode where we can see your notes as well.
That's okay. I don't have dual screens here, and so I have to, you're seeing the presenter view. So you're seeing all my typos and everything, which I must correct. Okay. I'm sorry, that's part of the humiliation of doing things live. Okay, so to track all this information, we apply tags to the equipment. Tags are a unique identifier for each piece of equipment as it's added. And then since each particular piece of equipment is unique, a unique type, they often get their own, their performance data is usually recorded on a equipment data sheet, and each equipment data sheet is unique to the type of equipment that we're recording. And here's a list, a typical list of equipment data sheets. The piping and let me reduce this here. Piping and instrumentation diagrams show all the items needed to control the process conditions. These document schematically all process, utility, and auxiliary equipment, as well as piping, valving, specialty items, instrumentation, and insulation, heat tracing, and its heat tracing requirements. It is owned by the controls and the stability engineer. So this is his answer to the question, can you make this process work? This is his answer. There's a lot of information developed or in conjunction with the P&IDs, such as instrument loop diagrams, process hazards analysis, operator control displays, operations and maintenance procedures, and in particular to us, equipment layout and piping layout. So in terms of piping, equipment and piping layout owners, the multiple data sets contribute to what the piper does. In the case of piping and equipment layout, we want to know the location, elevation, orientation, and separation of the equipment. And piping layout will then proceed per P&ID, per spec, and as permitted. Now, all these data sets contribute to pipers, starting with the equipment layout and then the piping layout. The pipers create a model of the physical plant. And based on experience with stakeholders, they strive to create a first draft that will pass muster with pipe stress, civil, structural, construction, maintenance, and operations. Clearly, the better experience of the piper, of the designer, the better the first draft of the plan. Equipment layout encodes the equipment position, orientation, elevation, and separation of equipment in the plant, and it also shows all places of piping attachment, such as significant nozzles on new and existing piping and equipment. It shows all other constraints on the piping, such as significant barriers, allowed routes, and so on. It's owned by the piping design department. Piping layout are the connections between equipment and the surrounding environment. It encodes the specified piping and its routes, points of support, starting and ending nozzles, vias and penetrations, and so on. It also captures instructions to procurement, fabricators, erectors who will fabricate, install, and check the piping. The piping layout is also owned by piping design. From the layout, additional information is generated, and we'll show this diagrammatically in a minute, such as fabrication inspection, pipe stress ISOs, foundation drawings, construction layouts, including for equipment placement, construction plans and sequences, and demolition plans. And here it is shown as an information flow. This information in the equipment piping layout is passed on to other users who will then create data of their own. So this equipment and piping layout and all the other data sets we've created become part of what's referred to sometimes as the digital twin. And it's a resource that's used throughout the life of the plant. Here's an example of piping isometric with several spools on it and their associated valves, fittings, and gaskets. So now we've completed an overview of the information flow and process piping design, and it's helped introduce the major information owners and their contribution to piping design. But there are other models other than information flow, because that's only one view of the plant. There's other view of the plants that are helpful to decision makers. And we'll talk about two of them very quickly. It's more of a topic for the PPD level 4 content that we're beginning to develop now. The first view has to do with design phases, contracts, work packages. The classical design phases separate the design into these major work packages, usually initiated by contracts. As they are created and studied, major data sets become more detailed with increasing confidence. The transition to the next work package is usually marked by a decision review against the business case of the plan, followed by a decision to proceed. This review and decision is usually referred to as a gate, decision gate. Bids to perform the next work packages can be considered an estimate of the cost to realize the plan. Another view, an object view, explains how low-level details contribute or roll up to the view most important to the customer. In this case, we're showing diagrammatic the view, the project business case. In the capital phase of the plant, the most important view is the capital budget and schedule. In the operating and maintenance phase of the plant, the most important view is the business case, the operating plant business case. Now let's, the demarcation, by the way, between capital and O&M phases is the start of production. So everything before the start of production is considered capital cost or capital expenses, and anything after, any expenditures after that are considered operations and maintenance costs. In some cases, people like to consider the demobilization, the shutdown of the plant, and environmental remediation after the plant as a shutdown phase. But we're only considering these two phases in this explanation. And if you look at the capital budget and schedule, beneath that, the costs that roll up to that are the design and procurement and construction plans. And they, beneath that is the cost, the actual cost to procure the site and equipment, the temporary services like construction, fabrication, and so on, and acceptance and commissioning. These are all capital costs that roll up to the capital budget and schedule. In the meantime, somebody's writing on my screen here. In the meantime, in the operation and maintenance phase, what rolls up to the costs are the finance processes and input output logistics costs. And these have to do with the operation of procured equipment, the operational site, the IT support, such as the digital twin, operation and maintenance, and plans, and the staff that execute those plans. So this is what sometimes people refer to as the object view of the plant. Somebody has written on my screen. So the conclusions, let's draw some conclusions here. The information flow helps identify data owners and their agendas. Piping uses multiple data sets to create their own equipment and piping layout. And the piping data is used by others with different data sets and agendas. There are other models of the plant that support different decision makers. And I want to make one final point that design is about the data and not the drawings. And drawings without quality assurance are useless. With that, I'll be interested in taking any questions you might have. Let me try to.
There's no questions in the chat, Bill. Whoever would like to put any questions forward, please just unmute yourself and you can chat to Dr. Beasley.
Okay, well, I want to thank you then for sitting through my talk twice. You know, I can see many errors that I have to correct in the talk itself, and you only see these when you try to show it to somebody else. They always show up in the middle of the talk. So I want to thank you again for attending the seminar. I'd like to see a show of hands before I leave, just for my own gratification and the reactions. How many thought this talk was useful?
Hi, Bill. This is Ivan Fernandez. Can you hear me?
Yeah.
Hello, Ivan. Yes, we can.
Hi. Hello, everybody. Thank you for the conference. I have a question. It's about the PNID. I would like to know who, from your point of view, who is the owner of the PNID?
Yes,
The process steering or control?
yeah, that is the so that's the people who I refer to as the controls and stability owner, and that guy is usually what's called the information and controls engineer. But what he's in charge of is the setting and preserving the conditions of the streams in the lines and controlling the equipment. So he's the one who maintains the process in the state dictated by the PFD.
Okay,
Bill?
thank you. Thank you, Bill.
Okay.
Bill,
Well,
there's another question here from Tim Phillips,
Okay.
and he's asking, does this apply for US or overseas projects?
This is I'm trying to get at the information flow in plant design that is independent of any particular country. It has to do with the essence of plant design itself. Okay, I'm trying to, the reason for this talk, the reason we developed this is I want to set a particular way of thinking about the data that will help you in quality controlling the data that you create as a piper. So and the reason I say this is that different people with different agendas own the data that you work with. If you find an error, you have to tell the owner that his data needs correction and he fixes it. So you're always dealing with different data sets that are owned by different people who have different agendas than you. Okay. And so understanding that is a critical outlook to have when you're dealing with piping data quality assurance. You find errors, but the errors may be because of data. You may find data to correct, but the person who corrects it is the owner of the data, not you. You have to tell them. So you'll find often in plant design all over the world, there'll be reviews where different parties get a chance to look at the data, they question it, but only the owner can change it. Okay? It's like the process guy, he's the only one who can change the process, not you, but you can ask questions about it. The P&ID, if there's a question about instrumentation, you can ask a question about it, you can question it, and he may or may not change it. So you're always dealing with different parties with different agendas, and they are the ones that own the data. That's where the data of record is. And that's why this topic, I consider it so critical when we deal with quality assurance, because you have to know who owns the data and that you're working from.
Okay, Bill, there's another question here.
Yes, I see that. The health and safety data team. This was a hard guy to classify. So I called him the guardian angel, without getting too controversial, of the project. He's the voice of the environment, the voice of the workers. He's the one who is overseeing what's developing and checking its integrity in terms of safety, health, and environment. So he's not. He designed some of the procedures, but basically he is a check on other people's designs and the voice of this agenda, the environment, health, and safety. So think of him as a guardian angel that applies almost at every stage. And I've seen it in projects where people are always going up to this guy and saying, how do they usually do this? How do they usually do that? And he's constantly reviewing project work with this agenda, with his personal agenda, EHS agenda. That's, Tim, that's correct. We go over this. Well, okay, the owner, when I refer to owner, it's almost a data term, and I'm trying to get our pipers to think about data in almost an IT sense. And when I refer to an owner, it's whoever owns that data set and is responsible for that and has that agenda. Okay, it's not just owner of the data like they're a clerk. They have an agenda about the data too. Agenda refers to the idea that they have a perspective that they want, that they have, that they are executing for the project. So I call it an agenda. So if there's something missing on a plan and sections or critical information at the build, it depends on what information is missing, but at ISO time, that's usually instructions to the fabricator, instructions to the builder, to the erector, even transportation. And so it's not uncommon. In fact, it's often the case that equipment layout and pipers will also enter instructions on their model to downstream users on how to use the data that they're creating. Like, I put the pipe this way, but I'm expecting you to install it from this side or that side. I'm expecting you to fabricate it this way. Here's a fabrication detail to use. They're instructing downstream users as to how to execute and create the information that they're putting into their layouts. Okay.
Bill, there's a message there from Tim Phillips. I'm not sure if you've addressed it.
I've just addressed that.
Okay. Tim Ivory. Okay.
Okay, so look, guys, again, the reason for this perspective and this terminology is to set up a kind of thinking in people doing quality assurance. It's not that you're doing it wrong, but in order to understand the way we have structured the downstream slides, all the work that Ron has done and all the other reviewers has made me change this presentation a lot to make sure it's, as an introduction, you begin to think about these things in certain ways so that when you get to our quality assurance slides, you have the right outlook and the right mindset, or a good outlook and a good mindset, and you kind of understand what you're trying to do. And all these procedures we discuss, they're fulfilling this information flow and this ownership and responsibility that I'm referring to. I have questions are missed. Okay. Ahmed, I don't understand your question.
Hello. Sorry, I have written two questions above Mr. Tim, or after the question of Mr. Tim, but I think you missed, or maybe you didn't notice about it. About the safety, my question is, in which stage HSE team or the safety team has input in this process?
Oh, well, let me
And
try
what
to
is the
address-
input, and also what is the input of safety engineer to the layout?
Yeah.
Thank you.
He begins collecting information at almost when the business case and the PFD are written. As soon as he sees what's in the pipes, he begins thinking about hazards from the process streams. He thinks about it then, and he begins thinking about what requirements do I have to set in the total design at that point. But he collects data from all the other users. That's why I put him aside on the chart as a kind of guardian angel. I'm afraid to show the slide again. I'm afraid I'll lose it again. But he's kind of up there as a guardian angel. But then he influences design all the time. He sits in all the reviews. He makes comments about, well, is that safe? Is that right? Isn't that dangerous? And people make changes. There are major design reviews throughout, but there is a process hazard analysis that is required by OSHA in the US and is required in other countries too, where people go through the entire plant and review it for safety and hazards. And he's part of that review, a big part of that review, a big commenter in that review. And it's usually done, the reviews don't begin, they start, but they don't begin in earnest until we have the P&ID, because the P&ID is our first comprehensive view of all the equipment in the plant. It's the first time we have a way to see everything. And that lets us review everything. So normally the process safety reviews are done in full earnest when there is a P&ID.
And is there a specific input or a specific input like the other disciplines like PID or BFD, something specific input from safety team to the layout?
Yes, his comments are made, but then the changes are made by the owners of the data on which he's commenting. So if he says something about the P&IDs, the process and stability owner will make the change. If he makes a comment on materials, materials owner has to make the changes. So it depends on who owns the data, how he reacts to the reviews. And yes, the comment that's made that the HAZOPs are reviews too is very appropriate. It's another kind of health, safety, and environment study. HAZOPs being hazard and operability studies.
Okay, thank you.
Well, Solomon has a question, and there are many data owners that I haven't mentioned here. Minor, I want to say minor, but you know, data owners that are contribute, like people that work on pumps, for example, mechanical engineers that work on pumps. They're part of the mechanical integrity of the plant, and they contribute data to piping. What the point is, there's many data owners with their own agendas that are creating data that pipe looks to. But if piping finds something wrong, the feedback is to the data owner. Piping doesn't make the change. He goes and asks for the change or questions the situation with the actual owner and their agenda. And so you get feedback all the time, and you've all seen it as pipers, where the guy says, I have to do it this way because of some other reason that I have, and I have a reason for doing it. And that's all, then case closed, that we're going to do it the way he wants it. If it's impossible, then that has to be resolved somehow. But yes, there's a lot of other pipers that, there's a lot of other disciplines, as you refer to, that contribute to piping. Disciplines are expertise, but owners are the ones who control what the data is. So the person who is the owner might be of a certain discipline, but it's important to recognize who's the owner of the data, who actually controls it. Okay, any other questions? These are good questions, by the way. Any other questions? Okay.
Paul's question, did you see that? Yeah,
No, I didn't.
Paul?
It's not a question, it's just a follow-up on
Okay.
what Bill was talking about.
Okay, go ahead and give the follow-up. Okay.
Well, I interpreted the question to mean is what information, where does information come from to feed to piping? I don't know if that's what the actual question was.
Who's this question, for me or?
No, from Solomon, his last sentence, what other disciplines supplied to piping to do their work? So I interpreted that to mean which disciplines are providing information to piping so piping can do their job. That's what
well, okay. There's the data sets that are being created are one aspect of the information, but the procedures, the predefined specs, the background procedures of the client, they're all considered by piping. But that's a pretty open-ended question. Who else might contribute? The answer is anybody that has an agenda might influence how piping does their job. And they may be an owner of some data that you have to work on. And you may have to, you question it with the owner. He is the one who is in charge of it. Look, when you're all working, you'll see a review document come out, say from piping, but there'll be a list of people who have to know what's on the, who have a review. There are people who will use your data, they'll be on the list, but there will also be people who own the data, they'll be on your list. So the owners are making sure you're recognizing their data properly, it's being considered properly, and the consumers, the later users, are trying to estimate what impact anything you say might have on what they're doing. So, you know, the list could be as big as you want, depends on how many agendas, how many owners. I'm just trying to highlight the major idea that there are major data sets and they have different agendas than you. Is that clarifying enough? Okay, any other questions? Okay, so I want to thank you for attending, and if you like this, if this is a good, give feedback to Catherine, and we'll try to schedule other seminars like this. I know that the Egypt and Spain chapter are planning a joint seminar in the very near future. I don't have the date in front of me. Would you like to comment on the date for that?
It's next week, I think, Jimmy.
Next week, it's next
at-
Saturday. And so it'll be a format like this, and I think they'll use Microsoft Teams. But anyway, there are several of the chapters that are holding seminars like this. And as I said in the introduction, if you like this, I might schedule some more like this for different topics. I see a lot of corrections I need to make, but that's okay. That's why I do this. So thank you
Well,
very
there's
much for attending.
Well, there's a message from Ahmed at the bottom. Look in the chat.
Yeah,
Okay.
sorry. يعني last comment. يعني is it يعني can you to do or can you put in the plan if we can make session about the bid estimate cost for piping for the bid phases project?
Well, Ahmed, I briefly touch on that when I talked about the phases, work packages, contracts model. There is another view to take of piping that has to do with how you manage the increasing level of detail, how you produce the increasing level of detail of the piping data, of the plant data. And I briefly touched on that, but I don't have time to develop that in this presentation. That whole presentation about phasing and so on, that's a topic for level 4. And we are working on that separately from this presentation. But all I wanted to deal with here, so I talked about a little bit in the other model, but I can't go into full detail here. That's the topic for level 4. But I did want to mention that there's other views of the plant that are solving problems like how do you phase work and how do you increase the level of detail and not overlook something, not make a big mistake, and how do you estimate costs, and how do customers roll up data to their business plan. I wanted to address other models, but I don't have time to develop them fully. Okay.
Yeah, I have to. Okay, and if you can also for your organization to take this point, if you have time to support us in this information, it would be nice. Yeah.
Yeah. Let me make these. I'll tell you what. Let me make these horrible spelling corrections. Okay. That I may have a PhD in mechanical engineering, but I didn't do very well in elementary school in spelling. Okay, so let me make these corrections as best I can, and I'll send out the notes to everybody who attended. Okay.
Okay. Thank you.
Hey, Bill, this is Garcia. If I may briefly address a little bit of Solomon's question in terms of what other discipline may have some input, if you just give me a minute just to just share with Solomon that as you had pretty much stated in the past, the PNID and who owns it. But I'll tell you there, Solomon, and I'm addressing this to you, that the PNID is a collaboration of once the process develop and they understand how the system may operate, other people that may have some input of what you do is, for example, control valves, flow transmitters, the flow elements, that definitely would impact of what you do. Also, if the piping is hot, the stress analysis might have to give you some input on what you need to trying to make happen on developing your layout. So they might not own the P&ID for say the process in itself, but these are other disciplines that may have that you may have to work with to develop your layout to satisfy their design requirement. And it's all that basically you could get a lot of that information from the P&ID, because the P&ID would definitely describe certain criteria in terms of the instrumentation. You know, if you have some hot piping, you better start thinking about building flexibility to it. So I just wanted to address that, you know, the discipline other than process that might affect you is some of these mechanical and PNC, and perhaps sometime the CSA, and which is the civil department, may not be able to build a foundation where you want it because the soil is not properly adequate, and you know, so all the discipline may require for you to do what you got to do, their input.
Yeah, and not to put too fine a point on it, you got to think as a piper, you're not a guy who makes pictures. You're not a guy who makes drawings. You're a system integrator. You have to physically realize all these devices and connect them up, and then instruct others on how to build, how to fabricate and build and assemble what you have chosen. It's a big job. You know, a high-level piper is a incredibly knowledgeable, interdisciplinary person, and today it's always been about the data, but today even more because we have data sets in big projects to populate. It's very much about the data, and it's about your understanding of how to quality assure the data. You are more of a physical system integrator of multiple agendas and multiple data sets. It is not an easy job. You know, everybody today, because of the demands on us, everybody is a power user, has to become a power user. There isn't any middle ground. So anyway, I don't want to make a big speech out of it, but yes, think of yourself as a system integrator and not as a man who makes pictures or a woman that makes pictures. We're not in the pictures business, we're in the data business. Anyway.
Well stated, Bill. Thank you.
Okay, I'll cut it off here. I want to thank everybody for attending. And if we get good feedback, we'll do more later. Thank you again for coming.
Thank you. Thank you so much, Bill. It was really good. Thank you.
Thank you, Bill.
Bye-bye, everyone.
See you.
Bye.
See you around.
See you,
Bye
Kevin.
bye.
See you,
Thank
Captain.
you.
Bye, Kat.
Bye-bye,
Jimmy.
all. Bye, Ron.
Bye, Catherine.
Bye-bye, Ron. Take care. Bye-bye, Jimmy. Good to see you.
Okay, Catherine, I'm going to stop and edit these slides, and then I'll send you a copy to distribute.
Super. Thank you, Bill.
All right, bye.
Bye-bye.